Okay, question number 7 from M1, June 2018, the GCE legacy paper, not the IAL paper. A particle P of mass 4m is held at rest at the point X on the surface of a rough inclined plane which is fixed to horizontal ground. The point X is a distance h from the bottom of the inclined plane. The plane is inclined to the horizontal at an angle alpha, where tan of alpha is 3/4. So that's one piece of information to write down. The tangent of alpha, so you know that the tangent of the angle alpha is equal to 3/4. That's the angle of the inclined plane. The coefficient of friction between P and the plane is a quarter, so mu is equal to a quarter, the coefficient of friction. The particle P is attached to one end of a light and extensible string. The string passes over a smooth pulley which is fixed at the top of the plane. The other end of the string is attached to a particle P of mass m, okay, where m hangs freely at a distance d, okay, at a distance d, where d is greater than h. This distance d is greater than this distance h below the pulley, as shown in figure 4. Okay, that means when this hits the ground, if this goes this way, if this hits the ground, Q would not have reached the pulley because this is longer than that distance h. That's why, I think that's why they gave us that information. Anyway, the string lies in a vertical plane through the line of greatest slope of the inclined plane. The system is released from rest with the string taut, and P moves down the plane for the motion of the particles before it hits the ground. First of all, state which of the information given above implies that the magnitudes of the accelerations of the two particles are the same. Well, it's because they're both attached to the same inextensible string. Okay, so the fact that it's an inextensible string, so you can just say both attached to. I guess they're only looking for the words inextensible, but it's more complete if you just put both particles are attached to the same inextensible string. Inextensible string. Okay, so they're both attached to the same inextensible string. Sorry about my writing, the pen's messing up a bit today. Then it says, write down an equation of motion for each particle. Basically, when they say an equation of motion, what they're trying to do is asking you to write down F equals ma. Okay, F equals ma. They're trying to make you basically do that for each of the particles. So let's first of all put some forces in here. So it's basically asking you to resolve the forces in a roundabout way. So you got the weight of each of the particles acting straight down always. Okay, so this particle, its weight, so that's 4 mg down here, and this is mg down here. You have the tension in the string here, you have the tension in the string here. Okay, resolving those forces in the directions which are perpendicular and parallel to the plane for this P. That's perpendicular, that's parallel to the plane, and that's perpendicular to the plane. Okay, so parallel to the plane, it's going to be 4 mg times sine alpha. Okay, because it's going, this angle is alpha here. You see, it's going away from the angle, same as this angle there. And here 4 mg, this will be 4 mg times cosine of alpha, because you've got to, the force, you've got to move it into the angle alpha. So whenever you move it into it, it's cosine of the angle. Okay, so that's, you also got the fact that there's friction acting. So friction always acts opposite to the direction of motion. It's going down, and friction's acting upwards. So this is F max because it has, it's moving, so it's reached its maximum possible value. You also have the reaction force when two surfaces are in contact with each other. So you have the reaction force acting perpendicular to the plane. That's the reaction force. Okay, so those are all the forces acting here. Now, tan alpha is 3/4, so we can use that to work out what cosine alpha and sine alpha is. So tan alpha 3/4, opposite over adjacent. So that's going to be 5, 3, 4, 5 triangles. So we can say the sine of alpha will be opposite over hypotenuse, so that's 3/5. And the cosine of alpha is going to be adjacent over hypotenuse, which is 4/5. Okay, so now we can start to deal with part B. So what I'm going to do is I'm just going to take a snapshot of this down there so I can write everything down a bit easier instead of having to keep scrolling up and down the page. So I'll just take a little snapshot of that and put it down here, and then write the equations of motion. When they say equation of the equations of motion, what they actually, what you're used to, I mean, this is quite a new way of asking actually, but what you're used to reading is for you to resolve the forces. Okay, so that's what they're asking you to do, resolve the forces, find, it's basically using F equals ma. So let's look at, for example, particle Q. Well, let's look at particle P. Or sorry, particle X. Is it X? No, P. It's at X. Particle P. What I'm going to do is, as it's moving down, it's accelerating this way. This is accelerating that way, right? Okay, so what we can do is we can take this as positive for P. So what I'm going to do is take this direction as positive. So I've got 4 mg times sine alpha minus the tension in the string minus the friction, F max, is equal to mass times acceleration, so that's 4m times a. Okay, so sine alpha is 3/5, so you got, so sine alpha is 3/5, so you have 4m times g times 3/5 minus the tension in the string minus F max. Now F max is equal to mu r. Let's find out what that is. So F max is equal to mu, which is 1/4, times r. Okay, now to find r, we got to resolve forces in this direction. I'll do that over here because it's pretty small. All you have for r is r equals 4 mg cosine alpha. 4 mg times cosine alpha. Okay, so F max mg times cosine alpha, which is 4/5. Okay, so you have the 1/4 times 4 cancels out. Okay, and you're going to end up with 4 mg over 5. 4 mg over 5. That's F max. Okay, 4 mg over 5. All right, so that's 4 mg over 5, and that's equal to ma. Okay, so if you want to just simplify that a little bit, that will be 12 mg over 5 minus t minus, so that's going to be 12, that's 8 mg over 5. Let's just write that in one step. That's 12 mg over 5 minus 4 mg over 5. That's going to be 8 mg over 5. Sorry about the bad writing there. Hold on. So you have 8 mg over 5 minus t is equal to ma. So m here is actually 4m. No, we already wrote that as m. Sorry, it's ma. That's 4ma. Sorry, 4ma. Yeah, I forgot to write the 4 there. Okay, that's 4ma. Okay, so 8 mg over 5 minus t equals 4ma. That's one equation of motion for P. And for Q, the equation of motion is basically pretty simple. It's going up, so t minus mg, t minus m is just m. Okay, so you got t minus mg is equal to ma. Okay, so that's for Q. That's for Q, we took an up as positive. So it should be neater than that, but those are the two equations of motion, one for P and one for Q. This is for Q. Okay, so there we have the answer to part B, and now we're going to go on to part C. Okay, so here are the two equations that we got from part B, the equations of motion. So we want to now find the acceleration of each particle, so we can solve these two equations by adding them together to get rid of the t. If we add them together, you're going to have minus t plus t equals 0. You have 8 mg minus, so 8 mg over 5 minus mg over 5 is equal to 4ma minus ma, which is 3ma. So we can simplify. This is like 8 mg over 5 minus 5 mg over that's actually, yeah, that's going to be 7 mg over 5. Are they both over 5? Whoops, nope, sorry, what did I do there? Silly mistake. 8 mg over 5 minus, you're going to add them together, so it's 8 mg over 5 minus mg. We're adding them together. Okay, the t's disappeared, equals, we're adding them together. It's going to be 4ma plus ma, that's 5ma. Okay, don't make a silly mistake like that. We have to do 1 plus 2. Why? Because that will eliminate the t's. So you're going to have minus t plus t is 0, which is gone, and you have 8 mg over 5, remember we're adding them together, plus minus mg over 5, which is 8 mg over 5 minus mg, and then you've got 4ma plus ma, which is 5ma. Now when you subtract these, this is like 8 mg over 5 minus 5 mg over 5, and that's equal to 5 times ma. So here, when you subtract them, let me just make a bit of space, you're going to have 3 mg over 5 is equal to 5 ma. Okay, the m's will cancel out, so you're left with a is equal to, you're going to have 3 over 25 g. 3 over 25 g meters per second squared. Okay, 3 over 25, that's right. So there we have the answer to part C. Okay, now for part D. It says when P hits the ground, it immediately comes to rest. Given that Q comes to instantaneous rest before reaching the pulley, show that that D must be greater than 28h over 25. So let's have a look at the diagram from the previous page. We know that the acceleration is 3 over 25g. So accelerating is 3 over 25 times g, meters per second squared. We've got to show that the distance d is greater than 28h over 25. All right, so now Q comes to instantaneous rest. So P hits the ground. When P hits the ground, it's traveled a distance of h. Okay, so while P is traveling, until it hits the ground, it's moved up to distance h meters. So this distance is h meters. Okay, so what we can do here is we can try to find what the speed of d is at the point when P hits the ground. So we're going to find the speed of Q when P hits the ground. It will be the same as the speed of P as P hits the ground. Of course, once P hits the ground, it's going to just stop, but just before it hits the ground, okay, the speed of P and Q will be the same because they're both connected by the same string. So let's consider P, okay, and let's write down what we know from Suvat while it is accelerating under the acceleration of the string. So we know the distance is traveled is h when it hits the ground. We know the initial speed is 0. We know the final speed is what we have to find. We know the acceleration is 3 over 25 times g, and the time we don't know. Okay, so we're dealing with here finding the speed v in terms of h basically. So v, we can use, we got v, we got u, and we got a, we got an s. Okay, so v equals v squared equals u squared plus 2as will work. So v squared is equal to 0 plus 2 times 3 over 25, 3 over 25g times s, which is h. So you can say v squared is equal to, that's 6g h over 25. So v is going to be the square root of 6gh over 5. That's v. Okay, 6gh over 5. Let me just make that a bit neater. Okay, so that's v. Alright, so that's the speed of P when it hits the ground, which is also the speed of Q at this point, okay, when it's already traveled H distance. Okay, so it's traveled distance of H. Now, it's going to reach a new situation. Once P hits the ground, the string becomes loose. It's not taut anymore. So once P hits the ground, Q is only moving under the acceleration due to gravity, which is acting down. Okay, so the new situation for Q is as follows. It's going just under the acceleration due to gravity. So let's just go back down here. Its mass was what? Oh, where's it gone? Hold on. Just a bit. Its mass is m. Okay, so it's going to have a mass of m. Okay, so mg is, and it's accelerating, okay, is g. There's no force up at all, okay, but we know that in its speed now in the new situation is the speed we just found. What speed did we just find? We found its speed was, what was it, root 6gh over 5. So its initial speed is root 6gh over 5. And we know that its final speed, so we got suvat here. So suvat, s, we got to find. Okay, we got to find what s is. U is square root of 6gh, and that's over 5. And the final speed is 0. Acceleration is, it's going upwards, so I'll take that as positive. So acceleration is minus g. And the time, okay, we don't need to know. But again, we can use v squared equals u squared plus 2as. So v squared equals u squared plus 2as. This time we're going to find what s is. So v is 0. So you're going to have 0 equals, this will give you 6gh over 25. And you're going to have plus 2 times minus g times s. So we can find what s is. So you're going to end up with basically 2gs equals 6gh over 25. So s, the g's will cancel. So s will be 3h over 25. Okay, s will be 3h over 25. So let's go back to our diagram over here. Let's go back to the diagram, which is over here. So we know that the distance is traveled. There's this distance we've traveled. Okay, this is the s that we just found. So it's the total distance is traveled. Okay, the total distance is traveled is h plus our s. So h plus our s. So what was our s? S was 3h over 25. So the distance, okay, that P travels, that Q travels is equal to h plus 3h over 25. Well, that's 25h over 25, that's 28h over 25. Okay, so as it's traveled 28h over 25, 28h over 25, then that means, if we think about it, that means, let's get the diagram back, that this distance d has to be bigger than 28h over 25. Okay, that distance must be greater than it because it's traveled 28h over 25 and it doesn't reach the pulley. Okay, it comes to instantaneous rest before reaching the pulley. Okay, so what we can say here, try and be neater than this, my pen's not working so well today. So you say, okay, as Q stops before reaching the pulley, sorry about my handwriting, therefore the distance d must be greater than 28h of 25. Okay, so Q travels, this is the total distance that Q travels. Okay, so this is the distance that Q travels, and of course if d is the distance between where Q first was and where the pulley is, then the distance d between the pulley and where Q was in the beginning must be bigger than the distance it's traveled, otherwise it will hit the pulley. And there we have the answer to that question.